All right, welcome, ladies and gentlemen, to week 15 Open Q&A, where I, Brian McLogan, am here to answer your questions and get you guys on with your week, getting ready for, again, another week of distance learning that I know many of you guys are going through. So I have some questions here that I'm going to go ahead and get answered for you. And then obviously, as you guys are getting into the chat, we'll kind of see how it goes. And if you guys have some additional questions, I'll be more than happy to do that. Kind of get some questions, but feel free to answer provide any questions in on the chat. And then once I'm done with these problems, we can go ahead and take a look at any other questions you guys may have. So the first one I think was just simplifying. I can't remember actually the full question, which was just going to ahead and simplify and simplify the rational expressions. Then we have another one, which is going to be a little bit more basic, or at least just with one variable. So we'll do those two. We'll go through a finding the inverse problem as well as a logarithm problem. So wanted to let you guys know of a couple of the things that are kind of new, or some things that I'm looking into that I think would be important for you guys, especially those of you that have come back, or maybe this is your first time being on an open Q&A, or you're a return user. Some changes that I am trying to make sure that this is like the best experience for you, especially if you have some questions or you're here to learn and get some help. So first of all, I kind of created the Discord, my Discord server, probably, I don't know, a couple weeks back to just allow you guys to be able to submit your questions. I make a post every Saturday, except for this weekend. I forgot to do it on Saturday. I was just busy. So I did make that post today on the community chat. And but that's always kind of difficult for people to post actually mathematical questions. So that's why I kind of came up with Discord, because a lot of people are using Discord, and it's just nice for a lot of people to kind of organize our content and questions that way. But it's also still a little difficult for you guys to submit questions full said. I love the Discord. I mean, already up to this point, you guys can see the link. It's free. You guys can see the link down in the description. And if you want to join, you want to have questions, or you want to help people with their questions. Up to this point, I basically have a channel from Algebra 1 to Calculus. And obviously, guys, if you're taking some other classes, we can open some other classes for you guys to, help and talk with each other about that. But it's really just another way for you guys to, connect with some people that, you can help people out, and also ask questions and submit, whatever you're having trouble with. But it was kind of getting a little difficult for me to be able to collect the questions that everybody has for me to submit. So one of the things I am now looking into is going into also using just a Google form. And basically I'm not getting away with Discord. I still want to push Discord. I love Discord. I was on there earlier today answering some people's questions. I use Discord for a couple other reasons. So I am constantly on Discord. And then obviously I'll just go ahead and check as many people's math questions as I can. I obviously, guys, cannot get to everybody's question. But that's why the community is so great over there, because people are, I might not be there every day, but it's every other day or every couple of days. And I come back and I already see that people are helping each other out. So I think the more that the Discord is going to grow, I think the more user-friendly and more beneficial it's going to be. So if that is something you are interested in, or something you want to check out, the link is in the description. Feel free just to go ahead and check it in. You guys can submit your questions there. I'll still probably go through that as far as when I'm looking for my open Q&A, but I think I'm eventually going to take away the open Q&A thread or channel on Discord and just try to work into a little bit Google Forms, just because it becomes a little bit difficult. It should be down. The link for the Discord link should be in the description. I did not create a Google form yet. I'm probably going to do that for next week. So I'll let you guys know on that. But the nice thing about Google Form is you basically can go ahead and submit a question, and then you can go ahead and upload a link to whatever file that you are, whatever question, you have. So you can either type in the question, or if you need to upload something, you can go ahead and upload it as like a picture or stuff like that. And then we can kind of go from there. And basically then every week, that'll be a little bit easier for me to just kind of organize stuff. But then also, since there's really not a back and forth, you have to be, specific on what it is you need help with. So a lot of times people, they'll give me good questions. They're like, I don't know how to do this, or this problem is confusing me here. And it's very detailed what they don't understand. And as a teacher, that's very, very helpful. And I know obviously from the student perspective, sometimes you just don't even know what you don't know. Like it's just, I'm confused and I don't even know what question to ask. I understand that confusion and that frustration as well. But it's also very difficult when it's like, I don't understand graphing or quadratics. I mean, those are very broad topics that, I'll spend, weeks or even a whole class period explaining something. So to try to nail an explanation or nail something for you guys in, less than 5 minutes is obviously becomes definitely difficult, right? So that's why I always just kind of ask for as many details and specificity as you guys can do. But I see some of you guys have joined in before I get, did I go through all these questions? I did go through all the questions. All right, so let's go ahead and see. I see nature is awesome. Addie, thank you so much for joining in. Kay, Violet, good to see you. Aiden, thank you so much, guys. Mir, Clutch Demon, what is Epsilon? Justin, good to see you. Bruce, see another one. Or is it a distance formula? There's 2 triangles, right? Tangent. I'm not sure what you are. Justin, I'm not sure if I understand your question from there. Bruce, yes, you finally get to see me live. I am live. And Joseph, thank you so much. Riza, Atlas, Planos, thank you guys for joining in. It is good to see you guys. Thank you, thank you, thank you. I do appreciate. So this is week 15 of the at least 2020. So I've been going live in at least this format since 2020, but I've been doing it for all the school year for those of you that are new. And again, guys, I go live every Sunday night at 9 p.m. Eastern Standard Time. So if you do have those questions, make sure you go ahead and submit them prior to the live streams, and I will do my best to answer them. Let's go ahead and get right into it. And then obviously, if you guys have some additional questions, make sure you put them in the chat. Hopefully if I can't get to them, hopefully some other people might be able to chime in. But depending on how long it takes me to do these math problems, we can maybe pick up some of your additional questions you guys have. All right, so on the first problem, I think looking into simplifying, the main thing we want to do is understand we want to write something in factored form, all right? And when we have something in factored form, what we can do is we can apply the what we'll call the division property. So let's kind of go through. And this was actually a conversation that was going on in Discord. So that's why I'm kind of approaching this a little bit differently rather than just doing the math. So let me kind of explain this like this. All right, 6 divided by 2. We know that answer is 3, right? And then we also know that 2 divided by 2. Oh, I'm sorry about that. I have my, crap, that's going to be annoying. I used to have my camera on my tripod and I'm working on to a new camera. So, but now I just put my camera on my monitor and that could be annoying because I know that's going to. So I'll try to write as slow or at least as like unobstructive as possible. All right. So we know 2 divided by 2 is 1. Okay. So the division property says anything divided by itself is 1. And then we know like 2 divides into 6 3 times, right? So it's like, all right, where are you going with this? Well, one thing we can do is we can rewrite 6 as 6. Oops, no. We can rewrite 6 as 3 times 2 over 2. And now you can see that if you apply the division property, 2 over 2 is 1. So that's just really 3 times 1, which is just 3. Now, obviously, if I'm saying what's 6 divided by 2, we don't need to go through all of that math of factoring out number 3 and then using the division property, right? We know 2 divides into 6 3 times. It's fairly basic there. But this idea of factoring and using the division property is going to yield us the same result as just doing the division that we kind of understand as like 2 dividing into 6. And actually, this is why that kind of makes sense. So knowing the foundations here of the division, what we understand is if we have something in complete factored form, meaning written as a product of factors, or a fraction written as a product of factors in the numerator and the denominator, then we can apply the division property. So what we have here is we can't divide across addition and subtraction. So please make sure you understand like 3 plus 2 over 2. You can't do, that does not equal 3, right? You can't apply the division property across addition. So we want to have everything separated by multiplication in the numerator and denominator. That's the idea of factoring, is rewriting an expression as multiplication. So right now, we have our expression written as multiplication, but nothing is the same. We can't apply the division property. So then we want to say, all right, can we simplify this any further? Like, is there anything else that we can do? Well, I recognize in this expression, both of these terms share a w, right? So they have a common factor of a w. That means I can factor out a w. I see what I did. Okay, so fun problem. So you factor out w. Actually, I didn't look at this, but now I see what they did. So we have a 4w minus a 3y times y plus w all over a 3y minus 4w, and then a 5w plus y. Okay. Now again, typically something needs to divide out, right? But again, for something to divide out, it has to be exactly the same in the numerator and denominator and separated by multiplication. So we technically have these three products or three expressions in the numerator and two expressions in the denominator. Nothing is exactly the same. However, I do recognize that these two terms are pretty much exactly the same. They're just kind of switched like positive and negative. So if I kind of like rearrange this, and let me just kind of go through this. Like if you have 4w minus 3y, that's the same thing as negative 3y plus 4w, right? You just flip them around, just make sure you keep the signs. Well, if I want to, that's also the same as factoring out a negative. Crap, I ran out of space. I'm spending a lot of time on this problem, so I'm hoping my explanation is going to be making sense, because it is a confusing, like it is like a tricky problem. Then if I factor out a negative, I have 3y minus 4w. Okay. Now, I know you can probably ask the question like, why would you ever do that? Or why would you ever think to do that? And again, because yeah, that's equal to that. Okay. And that's equal to that. I get it. But why would you ever think to go from here to here? Well, the answer is because if you obtain 3y minus 4w, then that's the same in the numerator and denominator, then they will divide out, right? 3y minus 4w, those will now be exactly the same, so I can apply the division property and simplify the rational expression. So I know it's not like intuitively like, oh yeah, let's just rewrite it like that. But again, your goal when simplifying rational expressions is going to factor out a negative now. Our goal is to have the same terms in the numerator and denominator so we can apply the division property. And there's nothing else we can do for these other problems to simplify. So therefore, now these are exactly the same. Everything's separated by multiplication. And then I hate going from left to right when you're going up and down, but that's what I have to do. So I'll do a negative w times w plus y all over 5w plus y. Okay. And then you could distribute that through and go from there. But hopefully that was at least helpful of an explanation. It is a kind of tricky one because most people are not going to like think that's what I want to do, or like, you know, that's the way you're going to go from there. However, in the next one, like this is one where I'd expect a lot of my students to be like, you know, all right, we need to simplify this. Again, we cannot apply the division property when we have expressions separated by addition or subtraction. So if we need to simplify this, we need to have them separated by multiplication. Well, the process of writing an equation separated by multiplication is factoring, right? So we need to factor. Now, these are quadratic trinomials. So obviously that's one of the major components, you know, of Algebra 1 and Algebra 2 of, you know, factoring and doing that process. And I know a lot of students struggle with that. Perfectly fine, because it is a little abstract process, but it is something that you just need a lot of practice and work with. So I'm not going to spend a lot of time going through the factoring portion of this. I'm just going to go through like, if we're going to simplify this, we have to have it written as a product of fact. We have to have it in factored form. So therefore, in this case, because again, let me put it to you this way. I can't divide this denominator into this numerator, or at least with the understanding, you know, like long division, you could technically, but again, like nobody wants to do long division, right? With that and see if it's actually this divides into that. Nobody's going to want to do that. Now in this problem, it made sense. Like, yeah, 2 divides into 6. Like we get that, right? There made no sense to do the factored form. But here, nobody wants to do long division to see if this divides into that. So that's why factoring is going to be our preferred method. So it might not have been preferred for numbers, but now when we have these expressions, it's going to be our preferred method. So in the factored form, I'm looking for what two numbers multiply to give you negative 11, add to give you a positive 10. So that'll be x plus 11 times x minus 1. And again, you can check your work. Remember, you can just multiply everything back through and make sure that you would combine the middle terms to get that exact expression. And then over here, I have what two numbers multiply to give me negative 8, add to give me a positive 7. So that'd be a x plus 8 times a x minus 1. So now you can see that my two terms, now I have terms. So again, to simplify this, they have to be separated by multiplication, check, right? They're in factored form. And you can see that these x minus 1s are exactly the same. So therefore, we could say my simplified expression is x over 11 divided by x plus 8. Addie, thank you. Now I gotta look. What are you guys doing? Why are you guys getting into trouble? We don't need trouble here. Whoa. Violet, I cannot translate back over. It's not coming back over to me. I apologize for that. But if you have further questions, feel free to reach out to me also on Discord, and we can kind of go through there a little bit more. But it's not translating, for at least on the Google, so I'm not able to pick up on that. All right. Cool. All right. So let's go ahead and move on to the next question here. Inverse problem. All right. So the inverse is going to be one of those problems that, it's a fairly standardized process. You're doing kind of the same thing over and over. You set the equation, and make sure it's in y and x form rather than using function notation. You can swap the y and the x and then solve for y. Now, this problem becomes a little bit of an issue, because I'm going to look at this graphically. Melanie, my Discord link for you guys to submit questions as well as to help each other out with your questions is in my description of this live stream. So you can just go to that description, or down in the description of this live stream, there's a Discord link, absolutely free. And you can go ahead, and that's where I'm taking questions for the live streams every week, as well as for you guys to kind of submit questions and help each other out. So if I was to graph this, x squared minus 4, my graph would look something like this. So 1, 2, 3, 4. Right? So 2, 2. Okay, so there's the graph of x squared minus 4. It's basically a quadratic being shifted 4 units down. Now, the issue with this, actually, I can't believe I didn't full screen this. So the issue with this one is that when you want to find the inverse of a graph, you need to reflect it about the y equals x line. Okay, so when I'm going to go ahead and graph this about the y equals x line, if I were to swap this, my graph would look something like this, I think. Yeah. Like that. There. Yeah. So hopefully, yes, that should be there. So I know my graph is not perfect, guys, but basically that's going to be the equation of my graph, okay? Now, that is an issue, though, because, guys, that does not pass the horizontal line test, right? This graph right here, wait a minute. Y equals x squared plus 4. No, I made a mistake. Dang it. All right. Now, well, either way, we have a mistake. We'll go ahead and go through this. I'll show up the graph to be the correct way anyways. But for right now, plus, yeah, it's going to be left. I guess, I don't know why my graph just looks weird, because it's probably horribly drawn, which it is. But either way, the main point that I'm trying to make is this does not follow the vertical line test, right? So you can see that's why we have this restriction here. So it says, yeah, find the inverse, but don't find the inverse of the whole quadratic. Only find the inverse of the quadratic when x is less than or equal to 0. So that is very, very important, all right? Because we're actually just trying to find the inverse here of here's the quadratic, here's the x values when x is less than or equal to 0. So only this negative version. So 1, 2, 3, 4. So when we're trying to look for the graph, we're only going to be finding the inverse here of this portion. So we're going to be taking this graph and reflecting it about the y-axis. Now, to kind of look at forget about the graphical approach, but that's why I wanted you to, that's the reason why I wanted to show you the graphical way so you can see why this restriction is so important. Now let's look at the algebraic. So if I want to find the inverse, all I'm simply going to do is swap the x and the y variable. Okay, and now we're going to solve for y. So I'll add a 4. So I have x plus 4 equals y squared. Then we'll do a square root on both sides. And then remember, when you introduce the square root, we have y equals plus or minus the square root of x plus 4. Now that's a problem though again, right? So that is x plus 4. That's under the radicals. So that's going to be shifting it to the left 4 units. The problem here is that we have plus or minus, right? So we don't know if it's a positive or is that a reflection from there. So that doesn't produce a function. Now, if we look at this, if we were to reflect this, the positive version, right, would look something like that. That doesn't make sense, right? That doesn't look like the reflection about the y, like that graph reflect about the y-axis doesn't work, right? However, if we take a look at the graph from here, and I guess my graph should probably look like that. There we go. My graph's kind of off, but it should be looking something like that. If you kind of graph it, if you look at it from the negative version, you can see that, oh, that actually looks like a reflection about that y equals x line. So we don't need to consider both cases. We only need to consider the negative case. So y equals negative x plus 4, or we need to use function notation. So we could say y inverse equals negative square root of x plus 4, right? Because you're solving for y, right? But again, remember the answer is to find the inverse. So make sure you're using inverse notation. And if you're dealing with functions, make sure you go back to function notation. All right, so next one is going to be a condensing problem using the logarithms. So I'm not going to get into the rules of logarithms, but I'll just kind of tell you basically what I would say to kind of follow here. So the first one we can kind of use when we're condensing is just using the power rule. So whenever we have a number or constant in front, we can rewrite that as a power of our argument. So in this case, we can have log base 5 of x squared plus log base 5 of y squared minus log base 5 of z cubed. Okay? So we can take that number in front and rewrite it as a power of the argument of the logarithm. Now the next thing is, now we can use the sum and difference rules of logarithms, or product and quotient rules. Sorry, it's been a while, of logarithms. But again, you can only apply those rules when your logarithms have the same base. Well, thankfully here we have the same base of 5. So what I'm going to do is I'm just going to work from left to right. So when we have the sum of two logarithms with the same base, we can rewrite that as a product. So I could say log base 5 of x squared times y squared. So instead of adding the two logarithms, you can rewrite that as a product of x squared times y squared minus log base 5 of z cubed. Now, when you're adding, you multiply. When you're going to be subtracting, that means you're going to divide. So therefore, we'll have log base 5 of x squared, y squared, all over z cubed. And again, remember that is the argument of the logarithm base 5. So there you go, ladies and gentlemen. That is a condensing problem. And then let's get into the last one, guys. And then obviously for you guys that are joined in a little bit late, just remember, guys, you can always submit your questions ahead of time before on my stream. And I apologize, guys. What's going on with my stream? Why am I buffering? Oh, that's not good. It says low latency. All right. Well, hopefully that gets better. I apologize, guys. If you have anything else in the chat, you can let me know if it's... The only thing I can check here is make sure... Yeah, I'm hardwired in, so often. Melanie asks how long do I go live? So I go live, guys, every single Sunday. Oh, stream looks good. That's weird. I guess it's just on my side. But yeah, I go live every Sunday night at 9 p.m. And then also since the world has basically taken over distance learning, I have been adding an extra stream to the mix on Wednesdays. I still do some math, but it's also just kind of there to answer questions, to help you guys out, give you guys a little bit of another outlet or maybe an excuse to just kind of get online, kind of get away from your own classes, your own questions. Like I just figured it was another way for me to answer questions from people, help them out. I do math problems, but I also just like to talk about distance learning and how that's going for teachers, parents, students, and kind of stuff like that. So, but my Sunday is my main Q&A, where I just really want to answer your questions, help you guys out what I can. So you guys can always submit questions in the community chat. And I think next week I'll promote it a little bit more because I get a lot of questions from you guys, especially like on, on Instagram and Facebook and on Discord. So I just want something that's like streamlined, where like I can literally just say, here's the link, submit it, and go from there. And obviously, guys, you know that if you submit a question, it's not likely I'm not going to get to everybody's question, right? It's just, or I'm always going to submit your question. I'm always going to be able to answer it. But that's why I kind of like the Discord. That's why the Discord, which is in the description, it's been very, very helpful. I mean, it's free, guys. People are helping each other, answering, like explaining things. I have people in Algebra 1 or pre-algebra. I have people in calculus and above. So everybody's kind of mixing together and helping each other out. And it's really, really cool to see that going on, because if you answer some questions, you learn more about like yourself. Like obviously, as becoming a teacher, I was actually amazed on how many things that I really didn't know. Like I knew them. I might have passed it on a test, but once you have to like explain things, you're like, wow, I actually didn't really know what I was talking about, or doing, and then you have to explain it. And then because you start doing those, well, why is that the case? Why is that true? And you have to go through that learning process as well to make sure that you can effectively explain things. Maybe not off the bat, but as the more you do that, it does kind of like creep in there. And so it really, really does help. They always say like teaching people is, sometimes the best way to learn, like you really get in depth of a lot of that material. All right. And then, all right, so let's get on to the last question. Yeah, I don't know. My live stream is frozen on my screen. So whatever. So the next one is a identity, sine of x divided by cosine of x plus cosine of x divided by sine of x. So the way that I explain this to my students when we did this problem, because this is like a very popular problem in identities, like if I said 3 over 2 plus 2 over 3, right? I mean, this is like a, I don't know, pre-algebra problem. Like it's just a fraction plus another fraction, and they don't have common denominators. So therefore we have to find the common denominator. Now the easiest way to find a common denominator is just to multiply the two products. Obviously you want to look for the common multiple that 2 and 3 share, that they both divide into. They don't divide into any other number before the number 6. So basically now what I do is I'm just going to multiply by a 3 on the left-hand side and a 2 on the right-hand side. Therefore, I have a 9 over 6 plus a 4 over 6, which gives me a 13 over 6. Okay, so you obtain common denominators, and then you just apply the operation to the numerator. Now, over here, we can see we have something that is not as familiar. We have sine over cosine and cosine over sine. So they're not common denominators. How does sine divide into cosine and cosine to sine? It's not like as easy as it was to intuitively understand like 2 and 3 dividing into 6. So one thing, at least we like from here, we know that 2 and 3 divide into 6. We know that 2 and 3 both divide into 12, right? But the LCD ends up being 6. Like the smallest number they both divide into is 6. But cosine and sine, like it doesn't really make as much sense as far as what do they both divide into. So we know that they both will divide into at least the product of sine and cosine. So the LCD in this case is just going to be cosine of x times sine of x, right? We know the product, sine of x divides into that product because that's cosine of x. And cosine is going to divide into that sine of x times. So now that we have identified our LCD, now we just need to obtain the common denominators. So on the left-hand side, we're just going to multiply a sine of x times a sine of x plus a cosine of x over a sine of x. So that'd be a cosine of x. Okay. So on this left-hand side, we get a sine squared of x over a sine of x cosine of x plus a cosine squared of x all over a sine of x cosine of x. All right. So now you can see that my denominators are the same. I know it's not as nice as the 6's, but they are the same. So now we can just combine our numerators. And the one thing we notice about our numerators is that is a Pythagorean identity. Sine squared plus cosine squared is 1. So we have 1 over sine of x over cosine of x. And then typically in this problem, we want to write them as not a fraction. So we'll use the reciprocal identities and say 1 over sine of x is cosecant of x, and 1 over cosine of x is secant of x. So there you go, ladies and gentlemen. I'll here for a little bit more if you guys still have some more questions, kind of see what else I can do. Also, just wanted to mention too, I saw Eddie in the comment asked, the other thing that I do submit, obviously, is, or another thing that I am adding into, I know this doesn't apply to everybody, but, you know, I do appreciate a lot of you guys that are supporting me on the channels, like as my channel members. That's awesome. I appreciate it. It's not anything that anybody needs to or has to. It depends on really what you're looking for or what you need. So as far as on this point, just to kind of let you guys know, I have just a lower like channel support just to, you know, help me just keep on continuing building up my streams and my channel. But then also for in the higher up ones, I'm also just adding in my lecture videos as far as what I'm doing with my students. So those are unlisted videos. I mean, I go in, that's what I'm doing with my students every day. And we're doing pre-calculus right now. So if you're taking pre-calculus and that's something that's like interests you, you to kind of want to see what that goes on. The videos are usually like between 10 and 15 minutes long, and it's just me with my class. So you kind of get that little interaction. And then also I'm supplying all my notes and answers that I have throughout this year for those join my class. But I know, guys, that's a lot of advanced stuff. I know a lot of you guys just have questions. That's why I'm here for you guys every Sunday night, and I want to try to do my best to answer your questions. But if some of that a little bit advanced features is something that interests you, feel free just to give it a shot and see if you like it. If not, cool. No big deal. I will be here and happy to help you out and answer your questions. So do you answer a question for me? Yes, I could, but you got to be pretty quick. Oh, big. I was so excited. I'm like, yes, I'll answer a question. I'm like, oh no, ambiguous case. I think I just did. How do you know if it's 0 triangles or only 1? All right. So I did this problem. If you want me to explain the law of sines, if you actually go on my channel last live stream, I actually spent a good deal explaining the whole ambiguous case. So if you want to actually see my explanation on that a little bit further, I would just say go in my channel, find my week 14 open Q&A, and then go to question number 5, and that will explain it a little bit more. But to give you just a quick little rundown, the no triangle exists when you have angle side side, and that third side is shorter than the height of what the triangle would be. So basically, it doesn't matter, you know, how you rotate that third side. If that third side is so short, right, there's no way you can form a triangle. So let me just kind of give you a random problem that would be like, and I think that what the weird thing is for people, it's like, why would you give me a problem that doesn't make sense, right? And it's like, that's just the way sometimes it can work. So let's pretend we have, let's have A, B, so we have a triangle. Yeah, so let's do A equals, I don't know, 45 degrees, okay? And then we'll have B is going to be, no, not B. Let's do C. Yeah, we'll do A. We'll do A is equal to 2. There you go. And I'll say C is equal to 25. All right, so I'm going to make up a problem that's going to be like totally crazy. So typically, when we're drawing oblique triangles, and an oblique triangle is a triangle that does not have a right angle, right? So this is not a 45, 45, 90 triangle. But here's A. Let's call this B, and that's C. Now this has to be 45 degrees. Now let's kind of draw this a scale, right? So we know 45 degrees. We're kind of familiar with 45 degrees, hopefully. So if I was going to draw something 45 degrees, that's going to be maybe like that, right? Roughly. So let's say this is 25. So here's A, that's 45 degrees. Now let's say this is 25 units or miles, centimeters, doesn't really matter. That's 25. That's big, right? 25, a lot. Now A is going to be on my opposing side, right? Now if A is only 2, like let's just pretend like this is somewhat to scale. If A is only 2, right? Here would be B. I don't know how big B is. I only have angle side side. Now I know this is not the scale. This is actually even worse than the scale. Like if B was 2, right? I mean, it might even be, it's probably going to be smaller than that. But you can see like how no triangle exists. I can't even like compress it a little bit further down to get it to connect. It doesn't matter how long B is. B can be as long as it wants. The problem, the reason why no triangle exists here is because this opposite side, A, is not big enough, right? It's not big enough to connect. So that's how the rules kind of work. I'm not going to go through them because I literally just did them in the last stream. But that's the reason why there can be no triangle exist. Now, technically on a math textbook, it's not that obvious, right? I'm doing a very obvious choice. So you're like, oh, wow, yeah, definitely there's no triangle to exist. But like typical textbooks will be like, it would be very, very close. And, therefore, then you'll see the math would not work. So when you do the math for the law of sines, what you'll notice is on your calculator, you'll get an error from that point. So that's another way that it'll kind of tip you off that, oh, no triangle is going to exist. There's other ways to look at it the way I find it with the height, but I'm not going to go over that. So, but hopefully that at least explained the general idea of why no triangle would exist. All right. A is on the opposite side because it is the smaller. A is on the opposite side because it's the opposite side of like, if you look at when you're labeling an oblique triangle, that's the opposite, like it's directly across, and there's B and B. So we label oblique triangles without right triangles, a little bit differently than we do our right triangles. Yes, Zach, that is the one. I used to do you subtract 180 from it to understand like that idea to see if it works. I'm kind of I've been teaching a little bit differently this year. So I'm not using that method, but if you watch any of my videos on the ambiguous case, in years prior, I did that kind of like technique as far as like the subtracting. All right. Okay, so the problem, oh geez, 4x squared tangent of x. By tangent of x. I think you'd have to use the quotient and the, Gabe, it's been a while from the thing, but I don't see a problem with you being able to separate that's a product. So you could use, that would be a product and the quotient rule to derive. It's been a while since I did the calculus, so I'm not going to get into the, I don't want to do the problem just because I want to make sure that my point is explanations at least going to be on point, at least for the problem. There's nothing else that I'm like missing. But yeah, that'd just be a problem of using the quotient rule and then the product rule. So you'd use the product rule for the 4x for the numerator, but then the quotient rule first for the for them. So that's just a standard product and quotient rule problem, or at least as far as I see it. Radian says geometric sequences. I don't know why I've been getting so many sequences. I guess I'm gonna have to go back and brush up because it's been a while, guys. I'm not covering any sequences series for a thing. I guess it is the end of the year, and that's usually when I used to teach it. But it's just not something I've gone through a lot, and I don't recall a lot of the formulas or the processes. So it's something I would just need to like review and to kind of think through a little bit more as far as the best approach and the best explanation. And so that's just not something I want to take the time at the moment doing for a live stream. So I've just kind of said I'm not handling any sequences. It's just been too long since I've been explaining it. But obviously I've been getting a lot of questions on that. So I will have to brush up on that. Yeah, just go check out that last stream. It's the question number 5. How to write 7x in the terms of sine. God, that's been a while since I did that problem. You'll need to use those formulas. Obviously it's, Melanie, you'll need to use your identities, and I'm not sure as far as all the identities that you have, what exactly you'd want to be able to use, but I would look into obviously using your sum and difference, using your double angle identities. So yeah, look into using your double angle and as well as your double angle and sum and difference form identities. But I'm not sure exactly as far as on that one, but if I remember correctly, we don't cover it in my class, so it's been a while since I did those problems. That's the approach I would look in for. Do I have any videos on? Yeah, I do. They're old. I mean, they're like, I don't know, 6 or 8 years old, which is like crazy, or maybe like 5, 7, but yeah, they're old. But yeah, if you just, guys, anytime you guys have any kind of questions, or just like problems like, hey, do you have problems on logarithms? You know, I always laugh when people are like, oh, help me with logarithms. I'm like, I don't know how to help you with logarithms. That's a very broad, topic. I mean, I spend weeks teaching logarithms, and also it depends on like, what do you mean logarithms? Like calculus, with derivatives, or are we talking like algebra 2, like basics, kind of stuff. So, but either way, the point that I was trying to make is if you go to my channel, on my channel, I have all my playlists that are for every course. You guys have playlists that are available. So you guys can go ahead and check those out from there. So hopefully that kind of just helps some of you guys out that are looking for certain content. I deleted Discord. Yeah. I don't know. It's one of those things, Wendy. I don't know if I think some people it works for me on some things, but then some things I'm still trying to figure things out. I'm going to go through the Discord and actually redo it. I think I'm going to create one for every single class and then do it by chapter. So it's going to be a lot more organized for people to be able to submit their questions. And I don't know, I'm hoping that will at least kind of help out. But yeah, sometimes Discord, if you're getting in there and people are going, like you have a lot of people online and all chatting away, it can get pretty out of control. So, yeah, I would just go through the thing. Just go through the playlist. I have a ton of examples. I mean, unfortunately, guys, I have so many examples I don't even recall how many, like what I exactly have examples on. But I believe, let me actually just look through your question again one more time. What did you have? You were talking about the series, right? I believe you use, okay, geometrics, how to solve for the common ratio if the fourth term is negative 54. And the seventh term. Yeah, I believe I'd have something. Yeah, because you just need to be able to find that common ratio. So you have the seventh term and the 54. Yeah, so you use the formula and you just you'd use the seventh term and the fourth term. And then from there, you would solve for your common ratio R. Yeah, you should be able to do that. I'm pretty sure I have a formula or at least a problem very similar to that. All right. Well, ladies and gentlemen, that is going to be it for tonight's stream. I hope I answered your questions. I hope I helped you out, and I do appreciate you guys joining. Just a reminder, guys, if you want to join next week or you have your questions answered, please make sure that you guys go ahead and follow me on my community post. You can always subscribe and hit the notification, so therefore you get notified. Otherwise, just make sure if you have those questions, guys, you can do it. You can post them on the community post. You can go to Discord. And then also I will be providing you guys a Google form. So therefore you can submit your questions in that way. So a lot of things coming up. I look forward to chatting with you guys and answering your questions next week. And then also don't forget my bonus stream for on Wednesday. Well, we will just kind of talk everything about distance learning and check in with you guys, do a little escape from this distance online world, even though I'm doing a live stream over distance learning, kind of same idea. But anyways, my point is I just want to be there, help you guys out, answer your questions, and take a little break from my own teaching and chat in with you guys. So otherwise, guys, hope you guys have a great night and a great week. And hopefully I'll see you on the next streams. All right. Cheers. There you are.